One here. Okay, so ladies and gentlemen, this is a topic which is going to take us through a couple lectures, and it is going to require us to sort of consider several different ways, several different principles by which we might design a set of test cases to test particular features. So when we think about testing, we think about testing an application in a general way, but testing, like change, always comes in a concrete form. We're testing a specific thing. We run a test case with particular inputs to test the system. Whether it's at the unit level, we're calling a method, or whether it's at the level of putting the system through a bunch of paces from, simulating a use case over time, or several use cases. Things are always concrete. We're testing it with particular inputs, particular values of a parameter at the method level, or particular user inputs on a form, right? We do this. We enter into this form, which is asking for someone's name. We enter nothing for the first name, nothing for the middle name, and only one name for the last name. And we press submit, and we see what happens. Right? That's a concrete case. Or we'll enter, a first, middle, and last name, but the last name is hyphenated, and we make sure that that works. Or, it is an apostrophe, D'Angelo, and we see, does it work? Does it take that apostrophe? Or we leave all three blank, and we see, does it give an appropriate error message, right? Those are concrete cases that we use to test, is the system working? And when I say when I use this term, is the system working, I'm not just talking about does it correctly handle correct cases. I'm talking about does it correctly handle incorrect cases. Now that may sound like a misnomer, but what's correct handling of an incorrect case? Yeah, it should give some sort of error message, right? So yesterday, trying to log into a Slack channel, I kept on entering my username and password on Slack, which I've had for a while, and I remember seeing, and I don't think my memory is off in this, I remember seeing a message which indicated my password was incorrect. So I said, go fix my password, and it sent me a notice which actually said, oh, actually, you don't have a password for this account. You're actually just not associated with this project. Click here to join the project. So actually, the error message was incorrect that I saw, and that's a distressing thing when you see an incorrect error message, or you don't see any error message at all. It's equally bad. So we expect our system to have appropriate handling for correct things, and appropriate warnings or guidance for things that are not correct, right? For us to know about them if we're dealing with user level issues. Okay, now I'm going to slip through some items here. So, ladies and gentlemen, I'm going to talk in the coming lectures about testing, including testing at different levels. And I don't know how much you get into this in 370 these days. Maybe you could tell me. I mean, do you talk about black box testing versus structural, or sometimes called Glassbox, or misleadingly white box testing? Did you talk about that? So testing a program without knowing its structure, just its functionality, what it does, versus testing it with knowledge about its implementation. Yeah. Okay. Glad to see that there's some coverage here. Both these types of testing are absolutely essential. It's not that one replaces the other. It's not that if we have access to the code base, we don't test it at a black box level. They're actually testing different things. I mean, behavioral testing or black box testing, functional testing, you'll hear those different terms for this. How well does the design match the requirements? To what degree are the requirements being achieved by this system? And instructional testing is really how well does implementation match design. I mean, so we plan this, for example, this algorithm to do this thing. Is it in fact achieving that? Okay. So here fundamentally we're testing requirements. Here we're testing aspects of the design and seeing if it's consistent with the implementation. Okay. You could argue here it's potentially design or implementation match requirements, because if either is broken, the requirement won't be met, the sort of plan for how the system would behave. So black box tests. I gave some feedback to teams when they were together with us as markers, and it was such a great thing to be able to talk directly to folks. Black box tests here are things that you should be able to begin work on right now, and indeed some of your teams had just exquisite test plan, beginning thinking on exquisite test plans. It was great. It was great. You were thinking through a lot of issues, and that's really good. You can start that immediately. Once the requirements are complete, you can start to ask, what should we be testing? What steps might a user go through that we could test? Is the system realizing this? Which use cases could we probe with our tests, right? This is not strictly a activity for the testing team in isolation. We can ask users about this. Here, for black box tests further down, those users or less computer trained individuals will often show bugs that we don't find. We mentioned that the other day. You can often focus on functionality to be exercised day to day by common user tasks. Now, there's a set of black box testing techniques which are not disjoint from. They actually have significant overlap for the Glassbox ones. But they're worth spending some time on. And again, I don't know if in 370 you talk about these specific ideas, coming up with specific test cases through reasoning about boundary values and equivalence classes. Did you talk about that in 370 at all? Like dividing up the set of possible inputs into categories of kind of valid and invalid, and then invalid and for valid, there's a set of subcategories maybe which share common characteristics. Did you talk about that in 370? A little bit? Okay, we'll review that. And there's a set of mechanisms that we can create, like decision trees, orthogonal arrays, and as we'll see next time, state transition diagrams that can help us with this. In addition to systematic testing, by the way, this can take place manually. It can take place at an automated basis. Right? You could have person enter a boundary value, 0. How many pizzas do you want to order? 0. Remember, there was a system years back. We had a thing called pizza ordering system, real-time pizza ordering system, and it was designed to work with a pizzeria here in town. You could order pizza, and actually, one of the people who created the system went on to found Skip the Dishes. Do you know Skip the Dishes? No, it's a very fast-growing company based over here in Innovation Place, where they have it's kind of sort of Uberization of delivery of food. So you can get food from all these different restaurants delivered by drivers with optimized routes, and they've hired many of my students, and some of my students helped direct the company, and one of them was in charge of, or was the key person on this pizza ordering real-time POS. And unfortunately, its name was real-time POS, which caused no shortage of joking. but it was reflective of an underlying grim truth. And I remember ordering with it, so I went to test it, right? And I asked for 0 pizzas, and good, it didn't charge me anything. I asked for negative pizzas, and it started to offer me money. So they're going to pay me money for the negative pizzas that I was going to be ordering. I think I also asked for a vegetarian ham pizza or something like that, and I was able to order some unusual ones. you could do all sorts of different weird things with it, and it would get itself tied up and give meaningless promises in terms of the delivery. I think I could order 1,000 pizzas at a time, and it's it would still promise rapid delivery. Manual testing is a very good strategy, and we can do boundary value testing. Order 0, order -1 pizzas, or what have you, and we could do extreme value, order very 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 high numbers. We can also do less structured testing. Here it's random, and random testing is generally done in an automated way. Sometimes I think the name for it is monkey testing. So basically, you have a program and it's just hitting this through a UI, using a UI framework, JRobot or Abbott or whatever. It's hitting your system, entering random numbers for different values, and just seeing, seeing if it stays stable and if it's still giving good results. This sort of random testing might find cases that are not handled properly, or it may find that after a certain number of tries, the system runs out of memory, it exhausts resources, whatever. So here you can use fully sort of random testing or semi-random, where you're testing within certain ranges. In general, you want to do a lot of exploratory testing, where you just try it out with different inputs. Okay, Glassbox testing. Here, you're focused on particular areas of the program often. You're testing a particular algorithm. You're examining particular partially computed values partway through an algorithm. You're confirming that you're hitting all the different ways different control flow constructs, ifs and whiles and so on, can go within a core algorithm. I remember a colleague of mine doing this at Microsoft with the core algorithm for dependency calculations in Excel. And so he was systematically going through, it was called FDUADDEF, he was systematically going through this algorithm and verifying that he had a test case to hit every possible case of all the if statements and while statements to make sure that it handled correctly all possible cases. So cases where a cell was empty, or cases where it had NA and entered circular cases, or what have you. Make sure it would handle those systematically. So he was taking into account the code and setting breakpoints in the code and observing its operation. So here you're focusing on certain areas, certain modules, observing partial values, observing data structures, etc. Yes?
Is this different from Blackbox testing?
It's just a different name for it. Whitebox is considered by many a less desirable way to say this, because whitebox sounds like it's opaque. The point is it's not opaque, it's glass, you can see into it, whereas white sounds like it could be painted white and you can't see inside of it. And the whole point is it's transparent. So that's why they call it Glassbox a lot of the time. Okay? But it's two names for the same thing. Richard Feynman, the famous physicist, Nobel Prize winner, arguably the most famous physicist of the latter part of the 20th century. He writes in his book, Surely You're Joking, Mr. Feynman, which is a wonderful book, if any of you have seen it. He writes that his father, when he was young, less than 10 I think, his father told him once or twice, said that 95% of the arguments in this world are actually just about labels. They're just about different names and different ways of characterizing something. And he said, don't get caught up in labels in life. Don't get caught up in how we describe something. You should be thinking about what the underlying system is, not how it happens to be described by different people. And he went through life as a physicist, and he writes in this book, I think in his 50s or 60s, he said, he's come to realize that, well, his father had an essential truth. With all due respect for his father, he disagrees. He says it's not 95%, it's more like 99% or 98%. People people get caught up in labels, and unfortunately, we often have the same different labels for the same thing. So white box, glass box, same thing. Okay, so let's talk about the underlying issues, though. When we are picking test cases, whether it's at a white box or glass box level or a black box level, we are trying to find particular values to use to test. Maybe it is a unit testing of a method. Maybe it's entering values in a form. And one of the most basic strategies is to characterize the set of inputs for a given form or a given field of a form or a parameter into a set of equivalence classes, a set of cases which should be handled kind of in similar ways. They trigger similar error conditions, or they trigger similar actions in the underlying system. They get it to perform similar output. There's several ways that we could define equivalence class, and I'll mention those. But the idea here is you have these equivalence classes, and you try to select a representative, at least one representative to test from each equivalence class. And then, beyond that, you test boundary cases lying between them. Okay? So let's talk about this. So suppose you had a square root function. What might be some equivalence classes that you'd like to test? So it is a square root function, and let's suppose for simplicity it just has a single input, a single double precision value input. What are some test cases you might want to test?
Negative values?
Yeah, negative values would be one. I want at least one negative value to see if it returns. You know, I left artfully, just chose not to specify, okay, how does it handle negative values? Suppose it's supposed to throw an exception for a negative value, right? Or better yet, return what? Those in 470? Yeah, monet, yeah, none. Okay, so good. Negative values. You want at least one negative value, right? Otherwise, you're not confident that with a negative value it does the right thing. It indicates properly that it didn't find value. Or maybe it's a function that returns complex numbers. You know, it returns for square roots of negative numbers, or returns something involving I or j, depending whether you're from math or engineering. So maybe it returns an imaginary component. But you want to just take at least one negative number. How about another thing? What else might you test?
Perfect squares versus
Perfect squares versus non-perfect squares. Great. So for positive integers, things that are perfect squares versus those that are not. That would be a great thing to test. How about something else? Yeah.
0.
Yeah, 0. Good. Another thing? Another fixed point of the square root operator? 1. 1. Isn't that cool? 2 fixed points, such significant numbers. Cool to me. Anyway, yeah. So 0 and 1. Those are good cases. So those would be those might be particular values we want to check. 0 being interesting. It's a boundary one, right? It's between negative and positive. But you see, the point is this whole equivalence class. It's like positive perfect squares. Perfect squares are a whole set of them. We want to try at least 1 or 2 from those, right? And we want to try at least 1 or 2 non-perfect squares. And we want to try at least 1 or 2 negative numbers to see if it works. Look, if we haven't tried it with negative numbers at all, we're not sure that it handles those cases properly, right? So the idea is you try at least 1 or 2 for each equivalence class, yeah? So if you're filling in that form with names, you try at least 1 or 2 that are sort of maybe names for each, 1 or 2 with each of different unusual characters, some where it's left blank deliberately. If you're booking flights on the plane, maybe you book seats that are in certain equivalence classes. So one might be, for example, first class or business class versus coach class, right? And you want to try 1 seat for each, and then maybe within those you want to try window versus aisle, just to see does it handle these cases. You don't have to do every single seat on this darn plane to make sure, but you want to, at least to prevent obvious errors, you need to at least try some from each class. After all, if you don't try a first class, maybe when you book a first class seat, it just treats it like a coach class and doesn't handle it at all. So you need to pass the red face test, to have at least any face plausibility in testing, to have any great confidence that your system probably is handling cases properly. You want to do at least some first class, some coach, and you want to be able to see, okay, is it booking, particular seats by position? Okay. After all, you might not know, maybe it's offering a middle seat when there is none on the plane. So you want to see, okay, does it give the correct seats in a given aisle or what have you? And the key here is to consider both valid and invalid cases. Cases where you're requesting something that is not possible versus something that is. Maybe you're requesting one that's already booked for a seat, right? Or a negative number for your square root function. Simple idea, important for building test cases. You can apply it manually, you can apply it in an automated way. All right? Okay. So, this is from one of Chen Kaner's book. This Testing Computer Software is a great book in computer testing. I think quite highly of it. Very practical book. And here it gives various suggestions for ways that equivalence classes that might be associated with certain types of inputs, right? And here the goal is to probe cases which are not allowed as well as cases which are allowed. Fairly straightforward to do. Can reveal whole classes of errors. If you don't do that, it can hide classes of errors. Okay, so what does it count in to be the same equivalence class? Well, does it lead to the same consequences in terms of leading to the same outputs, for example, the same error condition? Are they on the same side of the values that are allowed? Can they cause similar internal operations based on how the algorithm works? Is this Glassbox or Blackbox? Glassbox. Yeah, you're considering how this algorithm works. It treats these cases in a certain way. So you want to try some of those cases to see, okay, on both sides of that. Yes, if those are the case, if those are not the case. Does it maintain the value of certain predicates, certain rules for handling the situation? And generally, this is all about the fact that we have limited time to test. Testing is all about triage. We have limited time to test, limited resources. We can't do exhaustive testing. Let's test intelligently. Let's test things that are more likely to show errors. And it's about taking your limited time and using it judiciously, using it to test things that are, testing broad categories of items. Okay, so some tips here, again from Dr. Kaner's book. Consider looking for equivalence classes for each input field on a form. If you have a field, you have to fill in. What are the equivalence classes for that? What are the equivalence classes for invalid inputs? Maybe organize classifications in a table or outline, look for ranges of values or group membership. We enter someone who's already in the system or someone who's not in the system, an admin user versus a regular user or what have you. And groups of variables calculated to the same value, some range. Try to identify things will lead to similar output. So if you're doing a login screen, what are some things you might want to check? Okay, so imagine you have a screen for your long-term care app for the admin side so they can look at events. What are some sort of things you might want to test for that? So they have a login, username and password. What might you test for that? Give me some test cases. Username and password there. No input at all. Great, I love it. Yeah. Press submit, no input. Other?
Like invalid characters and stuff like that?
Yeah, invalid characters. Okay, there's characters which are not allowed as part of it. So all spaces, a username that's all spaces, right? I am the shadow. All spaces. My usernames are all just different levels of blank spaces. Okay, other things.
Exceeds maximum length or doesn't meet.
Okay, yeah. So it exceeds the maximum length of it, or it's lower than minimum length. Okay, good. Other things. Yeah.
The same as your password?
Okay, username and password are the same. Okay, I like that. Yeah, okay. Others?
Ones that are already used.
Okay, yeah, those that are okay. Suppose we're trying to log in, and so this is looking for ones that it's trying to authenticate an actual user. So we might use one that is a genuine existing user, or one that's what? That's not an existing user, right? Okay, or that is an existing user but has a
Wrong password?
good call. Or has a correct password, right? But at least we want to try one that's not in the system, right? So that, after all, if we were just testing, okay, I enter a username and valid password and it lets me in, I've missed a huge number of cases there that it might not be handling, right? After all, maybe someone enters a username and a wrong password and still lets them in. Could you imagine that happening? Yeah. I think that may have happened with the CSSS locker reservation thing. When you enter a username and wrong password, it still lets you in. Welcome, yes.
One educational institution that I won't shame and name actually truncates my password. So I can enter my full password, but it only lops off the front 10 or something and checks those. So I could actually enter a completely different password and still get in.
Wow, okay. That's disconcerting. That's very disconcerting. So that means if it were trying random passwords, it would have a much higher chance of getting in with a whole equivalence class of passwords that are all mapped to the same password. I think you start to get the gist here. So we want to be exploring valid things as well as invalid and see, does it operate correctly for each of them. This is always about concrete cases. So when I'm asking you as part of your deliverables to describe to me testing plans, overall plans for what you're going to test, are you going to test these paths, that's great. But what I'm really looking for is evidence also that you're thinking in concrete terms, like what are the specific cases we will be testing? And at some point it may become infeasible to list those in the deliverable. You may just refer me to this Google sheet which lists them. But you should be able to come up with these these ideas and list out particular cases. There's this username and that username and this is blank and that's overly large and this is this input is in this foreign language. Use a language which enters right to left. Oh, wouldn't that be interesting? See what it shows. And list out concrete cases, because after all, in the end, when you're going to run your system, people are going to be entering concrete cases. When you're going to test, you're running a bug party and you're testing it, you are entering concrete things. So you want to list out those concrete things. And then if they show results, if they find a problem, or even if they don't, sometimes you may want to automate them. So, you have a database of trial inputs. It tries these things, and it just goes and hammers the system trying these different cases, right? Right? try it with these particular inputs to this form, or particular inputs to this function. I'm looking for particular cases because we test with particulars. Does that make sense? Okay. I lack full conviction, but I'll take that as a yes. Okay, so here we could divide up cases, and we could list it out in outline form. Fine. Sometimes we divide it up into kind of a decision tree of sorts. So we have different possibilities. This is for an insurance. Gosh, okay, I stand remiss. This is maybe from Dustin testing book. I need to go find this as soon as possible. This is insurance renewal, and this is considering a case where you're going and seeking to basically renew a policy, and they're running this internally, and they look at particular users and they see how many claims they have, how many times they've said, hey, I got in an accident, there was this compensation that's needed. What's the age of the person, and then how do we change their premium? Do we send them a warning or not, or do we cancel their insurance? Okay, so here the insurance company is running this, and it's handling these different cases of individuals. So if an individual has put in a lot of different claims, for example, and they're fairly young, they haven't had too many years to rack those up, they might get socked with a higher premium increase and be sent a warning. And in the extreme case, this is like someone who's in a demolition derby or something. Here's someone who has five or more claims, any age, we're going to cancel their policy. So if we wanted to test this, we'd clearly, to have confidence our system is working, we'd want to test, for each of these categories, right? We want to be able to test, is each of these categories have a representative, at least one, for each of these categories, maybe more than one, to test this out. So if we were to think about this, what things might we test this against? So we're testing this with a particular person. These are rules, but we're testing it, as we do, with particulars. So we have a particular person. Who might we test? What might be a sort of good case to test here?
Age 25, age 26.
Good.
Age negative.
Okay, good. Number of claims.
Yeah.
We might have different numbers of claims. We might test it with 5 or more, see if it's always canceled, but make sure with 4 that it's never canceled. 4 or fewer, it's never canceled, right? We test things at boundaries between these equivalence classes, 25, 26, 5 versus 4. We're trying to pick things not only in the equivalence classes, but the boundaries between them, right? The last seat in coach class towards the front, or the last seat going back in business class, or what have you. We might test those, right? So these boundary cases are useful, and you can diagram it with a decision tree. Okay, now one strategy you'll see sometimes undertaken with this is to undertake a form of sort of systematic testing where each field, we consider each equivalence class and boundary case for each field exactly once, and we try that independent of the value of other fields. We at least try once to have a username that's not in the system. At least once a username that's blank. At least once a username that is in the system. And then for the password, one with a blank password, one with a correct password, one with an incorrect. And that's okay. That's a start. But we're potentially missing some things. And where this gets particularly big as an issue is when there are things that go together compatibility issues or things that depend on each other. And one of them is usernames and passwords, right? You obviously don't want to check a password that's incorrect as the thing that's always associated with the username that is correct. I mean, you want to check probably username correct, password correct, username correct, password incorrect, and then username not correct, password not correct, and see does it handle those cases. Another issue though is when you're dealing with compatibility issues. So suppose you have a system that requires both an underlying platform and a particular software on top of that platform. So the example we're going to be using is underlying platform might be Android or iPhone, and not so great an example, but okay. And then the question is, what browser are you using on it, right? You want to check that your web app works correctly with each platform, but also each browser on that platform. Does that make sense? And sometimes there are issues which only come up, it's specifically under the cases you're using Firefox on Android 7.0 that this issue comes up, and otherwise it doesn't come up. It doesn't come up for Firefox and Android 6. It doesn't come up for, Dolphin on Android 6. It doesn't come up for Chrome on Android 6. It's Firefox on Android 7. That's the issue. Surely you've probably encountered cases like that in your life. It's not one thing alone that is required to reproduce it. It's a confluence of two things. We might say it's a compatibility issue, right? It's an issue that's only manifested, with these issues. So those two together, Android 7 and Firefox, might jointly be a problem for displaying this HTML5 feature, right? No? Okay. Great. So here, what we'll often do is use what are called orthogonal arrays. The idea behind orthogonal arrays, ladies and gentlemen, if we have it helps us wend between two extremes. One extreme is we have a form. Say, maybe it's a form, maybe it's an issue of testing our system on different underlying technologies. And we consider each field in the form or each underlying technology in isolation. We say we try all possible equivalence classes and boundary values for this guy, this guy. These are three different sort of fields in this. Okay, we could do that, but the problem is it's not getting at this compatibility issue. And at the same time, we can't consider all possible combinations of these often because it's too many, or particularly if it's a configuration issue, testing all possible combinations of, say, operating system for the mobile device, version of that operating system, browser, might be too large for you to configure it. So what orthogonal array gives you is something in between testing just the values in isolation, each possible value, trying it each once for each possible value, and on the other extreme, trying all possible combinations. Instead, what an orthogonal array guarantees, and this is its key characteristic, mark my words, it tests each pair of possible values of each variable, okay, of each pair of variables. It doesn't test all possible combinations of values across all variables, but for any given pair of variables, say the server and the browser used, it will actually be testing all pairs of possible values between them. So instead of considering password independent of username, it's considering sort of pairwise the different possibilities. So valid username, invalid or blank password, valid username, overly long password, etc. And then same for invalid username. So here we might have browser, plugin, server, operating system. This is a bit dated now. And here, what we're doing is we're basically testing in different test cases particular values for browser, plugin, server, and operating system, but we're not exhaustively enumerating them. Instead, we've made the list very cleverly so that you can find in this list any given pair of browser on the one hand and plugin on the other. Any pair will occur at least once in here. But that doesn't mean that all possible combinations are listed here. It's far less combinatorially than would be there. So if we had 3 possible values for each of these 4 columns, what would be the number of possible combinations? So 3 possible values for each of these. Suppose it was just 1 column. We have 3 possible values. How many cases do we have to test? 3. Suppose we have 2 columns. How many cases do we have to test? 9. How if we have 3 columns? 27. Good.
27 times 3.
Good. I like it. So, 91 is it? Anyway. Sorry? 81. Thank you. Yeah, 81. So, so ladies and gentlemen, here we have a combinatorial explosion, if we just take it naively. If we added a 5th, 243, etc., it's just going to go up and up and up in a geometric way. With orthogonal arrays, what we can do is reduce that by orders of magnitude. Orders of magnitude to some things far smaller. For example, here we have 5 possible values for each of 3. And if we did it naively, combinatorially, 5 times 5 times 5 is 125. But we can actually do it in 25 if we consider an orthogonal array. So any given pair is guaranteed to be represented between a variable 1 and variable 2, and between variable 1 and variable 3, and between variable 2 and 3. But not all combinations are explored here. We could do this in 25 rather than 125. And ladies and gentlemen, bugs often come as pairwise compatibility issues. It could be that the issue is HTC with Firefox with Android 7. That is possible that a bug will only be revealed for that. But often it's just, if you have Android 7 with Firefox, this is an issue. Or if you have HTC with Firefox, this is an issue. It is more common to be a pairwise compatibility issue than a threefold compatibility issue. Okay? So orthogonal arrays guarantee, I'll state it again, a consideration of every possible pair of values between any 2 columns without guaranteeing all possible combinations. So they enormously reduce the number of considerations. This is another example: display mode, handheld, and minimal things. So huge savings, and there's free generators available for this. You can go plug in. Here's an example. You can go plug in numbers for what you want, or pick the type of items. It will generate these for you. So gives you a sense of the orders of magnitude. You can go down from a number of cases which is utterly infeasible to test to a number of cases which is perfectly feasible to test. And particularly if you're dealing with, input fields, it's one thing, because these things can be, it takes a while, UI testing is higher overhead, but left overnight it might be able to test all combinations of things if there's not too many of each. But when you're configuring phones, when you have to install Firefox on an HTC, with Android 6 and then separately with Android 7, it gets pretty tedious to have to set up all possible combinations. And using an orthogonal array can let you do so much more judiciously. Okay, Finally, I'll just note that there's certain types of testing, certain types of test cases, where you can confirm an answer much more quickly than you can derive it. So given an answer, you can at least cross-check it, or better yet, confirm it in a way that doesn't require too much effort. Okay. You know, you could at least do rough testing. For example, an airline route from A to B. So I fly to Sydney, Australia. Does it match some basic criteria? Is it better than, you know, a randomly chosen route to there in terms of the pricing, et cetera? And in some cases, I can actually just confirm, you know, yes, it matches the property I want to. I take the square root and I square it and I see if I get the number back of which I was taking the square root. It's confirmatory. I can check it really quickly. Okay. There are classes of problems where that can be done, or you compare a brute force algorithm against your heuristic and see do they give the same result. That's all we have time for today. Thursday, I'm going to be talking further, ladies and gentlemen, about this sort of test case design with a particular focus on path testing. Thank you, and we will see you then.